electron configurations together with me pointing. So they're going to help and inform all of you as to how to do this. So when you're reading electron configurations, you're reading left to right, top to bottom. And if you're all the way, say, down here to an element, you don't have to say 1s1, 1s2, 2s1, 2s2, 2s1, 2s2, 2s3, 2p1, 2p2, 2p3, and so on. You can go to the end of the block and just say that. So, class, we're going to go to magnesium, and we're going to start from the very beginning because of alphabet principle, and with energy level 1, S block, and we have 2 electrons in it. Okay? Then we're going to go to the second energy level, S block, with 2 electrons. And then to the second energy level, P block, with 6 electrons, and so on. So we're going to read this off all the way to, what element did I say? Magnesium. Here we go. 1s2, 2s2, 2p6, 3s2. 3s2. So magnesium's configuration, 1s2, 2s2, 2p6, 3s2. It ends on that block. Now, we're going to go all the way over to silicon. Reading from the beginning. Yes?
Just really quick.
Yes.
Can't you just do the NE, put it in the little...
Oh, we'll get to that.
What's that for?
That's the noble gas shortcut. We'll get to the noble gas shortcut. All right. So first we're going to go to silicon. We usually don't do that until we get to the bigger ones anyhow. So, 1s2, with me, 2s2, 2p6, 3s2, 3p2. Okay? 1s2, 2s2, 2p6, 3s2, 3p2. Now, we're going to do one in the D block. We're going to do iron. Are we ready? 1s2, 2s2,
2p6, 3s2, 3p6, 4s2, 3d6.
3d6. Okay? But when we get over here to copper in the D block, there's an exception. So I've got a little orange sticker on here. And copper is really close to having its d orbital filled, so it's going to want to steal an electron and make sure the d is already filled. Where is copper going to steal an electron from? The 4s, because of orbital overlap, in case that's a short answer question on the test. The orbital overlap means that this 4s kind of snuck in and filled before it was its turn. They're really close in energy, so that copper is going to steal that electron back. So, everybody from the beginning, 1s2,
2s2, 2p6, 3s2, 3p6, 4s1,
4s1,
3d10.
3d10. 4s1, 3d10.
Hey, how would you explain that in terms of energy levels on the alpha principle?
Well, we're going from lowest energy level to highest. That's what alpha says. Now, when you get down here to the really big elements, like something here in the 6th row, we actually jump down here. Okay, so if we're going past these first 3 elements, we need to jump down to this block. And this is the F block. Its energy level is 2 behind, so this is 4F and 5F. And we need to keep that in our pattern. Now we're going to do a big one all the way to the end, and then I'll talk about the noble gas shortcut. So let us do neodymium, because why not? What a cool element is that? So we start from the beginning. Are you with me? 1s2, 2s2, 2p6,
3s2, 3p6, 4s2, 3d10,
3d10,
4p6,
4p6,
5s2, 4d10, 5p6,
good,
6s2, 4f3.
4f3. Okay. Now, what if you didn't want to say all that or write all that out? You can use the noble gas shortcut. And the noble gas that comes before this row is xenon. So we can put xenon in brackets and just say xenon 6s2
was,
Okay, you can do that for, we do that pretty much for everything after the third row.
so
All right.
this is a 4F, like 4.
Yes, this is 4F,
Five.
and this is 5.